Imagine waking up one morning, lacing up your shoes, and suddenly possessing a speed no human has ever achieved. You step outside, take a breath, and take off. Within seconds, you surpass the speed of sound. You are running at 1% of the speed of light. That is nearly 3 million meters per second, or about 10.8 million kilometers per hour. At that speed, you could start your sprint right here, deep inside a crowded street in Delhi, and arrive on the coast of Mumbai in less than 1,000th of a second. Push that pace globally, and you could run laps around the entire Earth more than 70 times in a single second. This speed represents the peak of human imagination. However, the transition from standing still to 3 million meters per second is governed by the uncompromising mathematics of acceleration. Before you can cross continents, you have to actually start running. Your mass has to accelerate from a complete standstill up to cruising velocity. This chart shows the physical toll of that acceleration. Reaching 1% of light speed in a 10-second sprint subjects your body to roughly 30,000 Gs of force. For comparison, a highly trained fighter pilot typically loses consciousness at around 9 Gs. Subjecting organic tissue to thousands of Gs causes immediate structural failure. Internal organs are crushed, blood vessels rupture, and the brain is destroyed before you complete your first step. Since a normal body dies right out of the starting blocks, we have to assume your biology is magically indestructible. That is the only way we can see what your sprint will do to the Earth. You survive the acceleration and hit your top speed. Now you face an external threat, the Earth's atmosphere. At normal running speeds, air easily flows out of your way. At 10.8 million kilometers per hour, atmospheric oxygen and nitrogen cannot move fast enough. The air becomes a solid wall. Every molecule in front of you slams into your body. These collisions generate immense friction, heating the air and ripping atoms into a glowing plasma. In milliseconds, you're wrapped in a blinding tunnel of fire, carrying heat comparable to the surface of the sun. The violent displacement of that superheated air blasts outward. Glass windows shatter, buildings take heavy structural damage, and large trees are shredded. Moving this fast turns your body into a continuous atmospheric bomb, carving a scar through the environment. While the environment burns, the experience inside your head is completely disorienting. The human optical system processes images over fractions of a second. At your current speed, entire cities, mountains, and forests flash past before your visual cortex registers them. Reality degrades into a meaningless instant blur. This diagram illustrates Einstein's concept of time dilation. As your speed increases, time slows down for you compared to the rest of the world. At exactly 1% of light speed, this time-bending effect is mathematically real, but practically tiny. You wouldn't even notice your watch ticking slightly slower amid the physical violence of the sprint. Your mind is trapped in a blinding sensory overload, unaware of the superheated plasma trail you are dragging across entire continents. You have circled the globe in an instant, and now you face the final and deadliest phase of the journey. You have to stop. Any mass in motion carries kinetic energy. A standard 70-kilogram human body traveling at nearly 3 million meters per second stores a truly terrifying amount of it. This diagram illustrates your destructive payload. The physical energy stored in your forward momentum equals the explosive yield of a small nuclear weapon. The millisecond you hit a wall or break, all that energy transfers directly into the environment. The collision instantaneously vaporizes your immediate surroundings. Anything and anyone nearby is annihilated in the blast. The simple act of stopping effectively turns you into a geographic strike force. The end of the run is more dangerous than the start. The dream of absolute speed brings absolute freedom, erasing borders and rendering distance meaningless. The reality is far more isolated. You can never safely interact with normal humans or intervene to save the day, because every movement you make carries a catastrophic energy yield. You appear to observers as a blinding streak of plasma tearing across the horizon, followed by a shockwave rippling through clouds like a mysterious meteor. Achieving near light speed forces you into total isolation. It is the only way to prevent yourself from becoming a moving natural disaster. And that raises an even darker question. If just 1% of light speed can ravage the Earth, what kind of absolute terrors await at 10%?